I'm in the luxurious situation that I don't wish anything because I was in a position that I was in an environment where I had fantastic support. I had complete freedom to explore my ideas. And my boss, when I left PhD, said, "Don't worry anything, Zoltan. Just be yourself all the time, and then there will be success coming your way." So in when I look back, really, there's nothing with respect to my PhD where I would say, well, this could have gone better, or I could have received this particular advice in the beginning or at the end. So I'm probably one of those, I don't know how rare or how frequently this is happening, of being really fortunate during my PhD years. Mainly two things. Motivation. Early career researcher is more about motivation than having already certain skills. This is something that you expect from a postdoctoral scientist. Motivation, energy, and and then second, equally important, is a personality. It's basically looking for a person who fits our family, so to speak, extended family. There's more than anything, because if you have those personality features and at the same time a drive, then again, there's nothing that could go wrong. Frank Buchholz was speaking about their recent publication that came out December last year, I believe, about something that is still shocking to me, and that is a paper in Nature Biotechnology. And the topic there is sticking a zinc finger DNA binding domain inside the recombinase enzyme. This is something that you wouldn't do instinctively. Typically, when you make fusion proteins, you're attaching something either to the end terminus of a protein or to the very end. And this is an internal position inside an enzyme. And it's just shocking and absolutely surprising that this system, this fusion protein, can actually work. This completely changed my view on how to engineer proteins. Right now, I think the future is really bright and exciting for in vivo gene delivery. This can be done by viral vector systems. This is, of course, something that we knew all along. But whether we can employ them in vivo, of course, that's something that had to be established. But now the first reports and the first milestones are being hit with respect to non-viral technologies like lipid nanoparticles and just straight nucleic acids that are delivered into target cells, for example, T cells and the liver and other cell types by completely synthetic components and procedures. And I think during our discussions with respect to simplicity, reduction of cost for gene and cell therapy is something that is tremendous promise and opportunities for us in the future. My